Good day, dear students. Today we are going to start our fourth tutorial session, and first problem is from the chapter 7, numerical problem number 1. In this problem we have interest rates for different years. The term premium, which is 0.5 for 2-year and bond, and 1% for 3-year bond. We need to find or calculate the interest rate today on 2-year and 3-year bonds and define the curve. For a 2-year bond, according to the expectation theory, the interest rate would be the average of the 2 1-year bonds, which is 6% plus 4%. Which is 10%, and we divide this to 2 to find the average, and it equals to 5%. And then adding the risk premium, which is 0.5%. This gives us an interest rate on the 2-year bond of which is 5.5%. Okay. For the 3-year bonds, according to the expectations series, the interest rate would be the average of the 3 1-year bonds, which is 6 plus 6 plus, this is all the percents, plus 4 plus 3, and we will find the average, and this will give us 5% as well. 4.33%, sorry. And again, adding the risk premium for the 3-year bonds, which is 1%. Plus 1%, and finally it will give us 5.33%. So the interest rate on the 3-year bond equals to 5.33%. The yield curve would show the interest rate on a 1-year bond, which is 6%. The interest rate on a 2-year bond is 5.5%, and the interest rate on 3-year bond 5.33%. So it would be downward sloping, which is called inverted in the market. Okay, first year is 6%. Second year is 5.5%, and third year is 5.33%. Then you can see the downward tendency. So let's move on. Next question is numerical problem number 3 from chapter 7. So Mr. Midas has wealth of $100,000. This is his initial asset, initial wealth. So we can write down in the in his money demand equation. Then the next step is he invests 50,000 in bonds. Then we just subtract from in the equation this sum, and plus 5,000 more in bonds for every percentage point that the interest rate on bonds exceeds the interest rate on his checking account. At this point we will multiply $5,000 in the condition when the nominal interest rate earned by alternative non-monetary asset minus the nominal interest rate on money. So it will look like that, and we will multiply it by 100 because I and IM are in decimals, not percent. So for simplifying this expression, we will get we'll get this equation was the answer for our sub-question of numerical problem number 3. Let's move on. In the B sub-question, write an algebraic formula that gives Mr. Midas's demand for bonds. As we know, Mr. Midas's initial wealth is 100,000. So it means that his money demand, sum of his money demand and bond demand should be equal to $100,000. So by using this equation, we can we can construct the demand for bonds for Mr. Midas, which will be equal to this equation. Okay, let's move on. C sub-question. Suppose that all holders of wealth in the economy are identical to Mr. Midas. At this condition, we can see that the asset market in equilibrium. Fixed asset supplies per person are 80,000 of bonds and 20,000 of checking accounts. So this can be solved either by setting money supply equal to money demand or by setting bond supply equal to bond demand. In our situation, this is money demand equals to money supply. We have 20,000 of checking accounts. In the condition MD equals to MS, it will also be equal to $20,000, yes. So we can use the equation from the previous questions, which is demand for money. But here we should take in consideration that checking accounts pay no interest rates, which mean that in this situation, checking account represents IM, which is the nominal interest rate on money. So we will consider that IM is equal to 0. Then our equation will be, at the end we will have this equation, this final equation, where we can find I, which is interest rate. So at the end, we will have the interest rate equals to 6%. So let's check it by the bonds, demand and bond supply. So when the asset market is in equilibrium, then we will have bond demand and bond supply is equal to each other, and it will also be equal to 80,000 according to the equation. And then so we have the bond equation, bond demand equation is like that. Again, our checking account accounts pay no interest, which is 0. So we will have only I. I equals to $80,000. So we have the same equation at the end, and our interest rate on bonds in asset market equilibrium is also equals to 6%. Okay, let's analyze problem number 6, where we have the real money demand function. Also, we have the real output, which is constant over the time. Real interest rate is also fixed, and we have the growth rate of nominal money supply, which is 10% per year, and that this growth rate is expected to persist forever. So what we need to find is the real money supply and the current price level. Assuming that the growth rate of nominal money supply and the real income are constant over time, in this case, the expected growth rate of nominal money supply and real income equal their current growth rates. And our expected inflation rate is equal to the current inflation rate. At this situation, we will have that, as I said before, that the expected growth rates of nominal money supply and real income equal their current growth rates, which is this sum. Yes, their current growth rate of nominal money supply, which is 10%. Okay, then we know the equation of the nominal interest rate, which is equals to the expected real interest rate and the expected rate of inflation. In our situation, we know that our the expected rate of inflation is equals to the current inflation rate. Then we can use this amount instead of this. So just using the indicators that we have the amounts, we will have our real interest rate is 5% plus current rate of inflation is 10%, and we have the 15% of nominal interest rate. And then by using the real money demand function, we can find the values of the real supply, real money supply, which is 10, and the current price level, which is equal to 30. In this case, we substitute the inflation rate amount by 5%, and the calculation is the same. And at the end, we will have the current price level 20, and this can be explained by the slowdown in money growth reduces expected inflation, increasing real money demand, thus lowering the price level.